In this video, we're going to study the internal pneumatics of a ventilator. What you see in front of you on the screen is the block diagram of a ventilator. It starts with an input, which is the airflow and oxygen flow inlet, which is denoted by 1 and 2. And the whole system, it ends with the air being delivered to the patient's lungs, which is the output denoted by 12. Power supplies, they play a vital role in the functionality of mechanical ventilators. Ventilators typically get their power from electricity or from compressed gas. Electricity can be sourced from the wall outlet at 100 to 200 volts AC at 50 to 60 hertz. They could be also powered by batteries, which are from 10 to 30 volts DC. Batteries are usually used to power ventilators that are used for home care and transport. So if you have a wall ventilator, you can't move it. If compressed air is being used for power, it will usually be sourced from tanks or from hospital outlets. Now, the whole system, it uses a lot of valves because when you're using air, you need to make sure that there's no backflow. And what you see in 3, 4, 5, and 6, these are all valves that prevent backflow of air. So you have air coming in through 1 and oxygen coming in through 2, and it is stored in block number 7, which is the tank. From block number 7, it goes to block number 8, which is the mixer. Now, the mixer has to mix the right amount of oxygen with air, and that's why we have gas sensors, which sound an alarm whenever the said level of carbon dioxide or oxygen goes above the level that is required for normal breathing. Here you have the CO2 gas sensor, and here you have the oxygen sensor. Now, based on the inspiratory rates of the patient, which are detected by sensors that are placed in 18 and 20, you design the system in such a way that the air that is supplied to the patient has just the right amount of pressure that is needed for the patient to breathe it in. So the inspiratory and expiratory pressure is detected by sensors, and just the right amount of pressure is provided to the air so that it is pumped inside the patient's lungs. Another important thing is that the air that is supplied to the patient needs to be warmed and humidified. And that's why we have a nebulizer that is part of a ventilator. The nebulizer helps to humidify the air. And this whole block diagram, this whole block here, the I block is the nebulizer, and these are the components of the nebulizer. You could imagine the importance of a nebulizer because if dry or arid air is supplied to the patient, it could dry the lung out. So it is a very important component. With all of these parameters and blocks in play, we get a ventilator that helps pump the right amount of air with the right amount of pressure, with the right amount of humidity inside the patient's lungs.